Hi everyone, it's Brandine here. This video is made to accompany Lab 1. It's a walkthrough of how to build Lab 1 in Multisim. These details are also in the lab instruction themselves, but it might help you to watch the video as well, or if you find anything troubling. Normally what I would do after I've opened Multisim like I have here is I would go File, Save As, and I would save this design with a different name. I'm not going to bother to do that now because I'm just building it for the purposes of this video and I don't need to save it. But normally you would want to do that and give it some sort of meaningful name, such as Tech 150 Lab 1, something that, you know, when you need to find it later, you're not searching through a bunch of files all called design. Okay, so my first advice to you is pick File, Save As, and give this a sensible name. Okay, but I'm just going to build. So the goal to keep in mind here is we're not using Multisim at this point to become Multisim experts. We're using Multisim as a tool to try to understand what you're seeing in the circuits that you're studying and understand how those circuits work. So the main things that we want to look at is some components, but also some measuring equipment so that we can get values from those circuits and components. So let's build a simple circuit. I'm going to go to the Place menu option here and pick Component. From the group, I'm going to look under Basic, and I'm going to go down to Resistor. And I know I'm going to use a couple of resistors in this design. I'm going to grab, let me scroll up here, some 560 ohm resistors. Now you can change the tolerance here if you wanted to reflect what you might be using in the lab, but I'll just leave that to 0% for now. And I can say, okay, notice that this menu is going to, it's going to close, but it shows my component there and I can move it around on the screen. I haven't put it down yet. Once I click, it's now placed in the design and this select a component menu pops back up. And that's a setting option that you can change, but it's actually very useful for us to have it pop back up so that we can pick more components because we need more than one resistor. So let's grab another 560. And then let's go back and grab a couple of 330s. So we'll grab two 330 ohm resistors. So one there and another one here. And also, and then, so I'm at the point now where maybe I want to stop adding components for a second. So I can just close this window once it's popped open like that. And if I decide oh, you know, maybe I need to change one of these resistor values, I can actually double click the resistor, and under the value tab here, I can change this resistance value. So if you're doing a lab that requires you know, changing a load resistor a couple of times and measuring values, you don't have to take out that other resistor and put the new resistors in and rewire them every time. You can just open the resistor and change the value. Okay, I'm going to leave that at 560 ohms and I'm going to say okay. Now, in the circuit that I'm doing for Lab 1, the resistors are all placed vertically. So I'm going to click on each of these resistors and say Control R to rotate them so that they are facing up and down like so. And then I'm just going to give them a rough arrangement. I'm going to have this one over here. I'm going to have, you know, this 330 in parallel with a 560 and then another 330 down here. And before I start wiring, I'm going to want to add a power supply. So let me go back to the Place menu. I'm going to pick Component. I am going to pick, instead of Basic, I'm going to pick Sources. I'm going to choose Power Sources from the family. I'm going to pick DC Power Supply. I'm going to say OK on that, and I'm going to put it over here to the left there. And then I'm going to pick ground. Okay, so I'm going to pick this ground symbol, and I'm just going to put it down there somewhere for now, and then I will say close. So now I want to wire these things. So I'm going to wire the power supply to this first resistor. So I'm clicking on the end of the power supply, and then I drag this wire, and then I have to click it again to get it to connect to this resistor. Okay, so I'm going to click here, I'm dragging it over, then I'm clicking again to get it to connect. I'm going to connect these two. Okay, I'm not being super neat about my connections here, but you can get the idea. And I need to route this. Now, if I need to turn this corner, instead of this, like it's moving the whole line up, I don't want that. I can click and then start going up, and it sort of anchored that wire there. And if I want, I can drag it over, make it look a little neater. I'm going to wire this last resistor here, and then let me add a ground. Okay, so now I have a simple circuit. Eventually I want to simulate this circuit, run the simulation so I can see what it's doing. I'm not going to do that yet because I don't have any test equipment in there, and I want to see some values from this circuit, right? I might want to measure a voltage or a current, and so to do that, I'm going to have to put in some sort of test equipment. So let us make the easy choice. So if I go to the, let's see if I get this right, the place menu, and I pick probe, I can pick voltage or current probe. I might want to add those. I can also get these options just here on the toolbar, but if you don't see them here on the toolbar, it's place and probe. Okay, and sometimes I get confused because in simulate there's also instruments, and we're going to take some of those too, but the probes are over here in the place menu. So I'll take them from the toolbar. I'm going to grab a voltage probe, and I'm going to click to place it where I want the voltage to measure. It's going to, right now it doesn't say anything for these readings because I haven't run the simulation yet, but when I do run the simulation, I will get some readings by default here with respect to ground. I'm going to put a current probe in the same spot, actually. So here is my current probe. I'm going to click to attach it to the wire. And you can see the arrow. It's going to give me the current through this this particular wire. Okay, and that's kind of nifty because I didn't have to break the circuit to add that in. So now if I press this little run green arrow, you can also press F5, or you can go to the simulate menu and choose run. If I do that, I can see that I've got 12 volts here, which makes sense because that's directly connected to my 12 volt supply, and I have 22.3 milliamps here. Okay, so I'll stop my simulation so that I can make more changes to the circuit, and I'm going to add a couple of meters. So I'm going to go to Simulate, Instruments. I'm going to add a multimeter, and I can put this multimeter here. I can also click on this multimeter, say Control R. I can rotate it just so that the leads point in the direction I want. I can attach this multimeter because I want to measure voltage across this resistor. I can attach it like so, and I might want to drag that wire over a little bit, and then I can double click on this multimeter and I can make sure that it's set to volts and DC. So the flat line being DC, the curved line being AC, V for voltage. So I've got DC volts selected here, and I'm going to leave this little window open because I want to see what value appears there when I hit the run button, and you can see I've got 4.634 volts. Okay. Now, there's another sort of meter that I can add. So instead of the multimeter, I can actually add a component. I can go to the, oh, I got to stop my simulation. So stop that. Go to Place, Component, And this time from the group, I'm going to pick indicators, and I'm going to pick voltmeter. So I can actually grab a voltmeter as a component. Let me grab this vertical voltmeter because it's going to put the leads top and bottom. That's going to be convenient for me. I'm going to put that here to measure the voltage of that bottom resistor. I'm also going to grab an ammeter, and I'm going to grab one that has the HR designation, so it's flipped it around so that the negative lead is on the left side here, and I like that. I'm going to set that there for now, close the component window. So the voltmeter I can attach directly, but first I'm going to delete this wire, and I have to insert my ammeter into the circuit, right? The ammeter has to be inserted, just like if you were in our actual lab, into the path where you want to measure the current, whereas the voltmeter just gets connected in parallel with wherever you are trying to measure the voltage. So now I have the first circuit here. I can run it. And you notice that the current here through the current probe is actually the same current here through the ammeter, because this current splits across these two branches but comes back together and then flows back to the back in that path. So the current here and the current there are actually the same current. I see I have 7.365 volts across this resistor. I have 4.635 across this resistor. Not surprisingly, that is adding up to the 12 volts of the supply, and that makes sense to us. Okay, so there's my simple DC circuit. Let me add a simple AC circuit. So I'm going to go back to my place menu, grab another component. I'm going to use a voltmeter for this AC circuit as well. So while I'm here, I might as well grab another one of these vertical voltmeters. I'll just set it off to the side. And then I'm going to go back into the basic group. I'm going to grab a couple more resistors. I will grab a 560 ohm resistor. Now I'll place this resistor down. I'll close this just to show you that I could click on this resistor, do a Control-C, Control-V. Now I've got a second resistor. I can double click the second resistor. I can change this value to 1K. It's going to understand that that means 1 kilo ohm. That's another way to get resistors onto your design. I'm going to move this resistor up. I'm going to bring this resistor down and rotate them so they are vertical. I didn't have to do that. I'm building a little series circuit here, but visually I want them to look like that, okay? It doesn't actually matter, but it makes it easier for me to think about the circuit, and it makes it easier to remember what I'm measuring and where I'm measuring, so that is the wise thing for me to do. I'm going to go to Sources, Power Sources, and grab an AC power source now. And I'll put it down, and I will grab a ground reference. And close. Okay, so super simple circuit, just 2 resistors in series. Connecting all my wires. Remember, I'm clicking here so I can turn the corner and then clicking again to connect the ground. I'm going to connect in this power supply. Now first, I'm going to double click this power supply. I'm going to change the mode to AC because now I'm in an AC circuit and I need it to measure RMS volts instead. So I'm going to set it to AC volts, and I'm going to put it across this resistor, and I could Control-C, Control-V to grab another multimeter, or I could have grabbed that from the Simulate menu. But I'll connect a multimeter in here just to show you the settings for the multimeter. Let me double click. Oh, multimeter 2, it opened its window on top of the other one, so I'll bring it down. I want to pick AC volts. Sorry, that's current. I want to stay on V for volts, but click the squiggly waveform to get AC. So I've got volts, but AC volts. And I'll leave it open so that when I run it, I can see the values. Now the last instrument I'm going to grab from the Simulate menu, Instruments, and I'm going to grab a simple Multisim oscilloscope here. And what am I using it to measure? Oh, I did 2 channels. Okay, so I'm peeking at my design off to the side here, but I'll set it down here. The negative lead needs to connect to ground for both channels. So I can join them together, and I can move this wire over just to make it look neater. I'm not having an easy time of moving it, but we'll make it happen here. Okay, so there we go. And channel A, I'm going to connect to the supply. Channel B, let me connect channel B to this, the top of this second resistor. So it's going to measure the voltage. I'm measuring, because remember, oscilloscope grounds can only go to ground, right? So the channel A is getting the whole supply voltage. Channel B is just getting the voltage across the second resistor, so it's going to be less. So let me run my simulation. You can see that I have 76.9 volts RMS across the first resistor, 43 across the second, adding up to my 120 volt RMS of the supply. If I open the oscilloscope, you can see that my waveforms aren't immediately visible. I need to change the scale of this volts per division. So right now it's set to 5 volts per division, and my 120 volt waveform is gone right off the screen because it's so large. So let me set both channels to 100 volts per division, and you can see there are my two waveforms. Now with the waveform jumping, let me just set my trigger level to single for now so that it stays still. The scale is 10 milliseconds per division. So you can see that each one of these big squares is 10 milliseconds of time, right? And we could actually measure the frequency from this by counting how many divisions or partial, like fractions of divisions, make up one waveform. And to measure that, the easiest way is actually to measure peak to peak, as opposed to trying to read the middle. Although I know this scope is actually, the middle is truly the middle, and that's easy, but peak to peak is sometimes a bit easier to see. And as long as we're measuring from two 2 points that are the beginning and end of a cycle, then it's fine. But multiplying the number of divisions by this times per division would give us the period. We could invert that value to get the frequency. So if I read this, these little ticks are 0.2 of a division, and I'm getting now this is hard for me to read. I'm just going to see if I can change the position of this. But maybe I'll just count. So let's see, 1, 2, 3, 4, 5, 6, 7. I have 8 of these little 0.2 ticks. I'm punching this into my calculator, but I'm not telling you the answer because I want you to figure it out for yourself. And yes, it does give me a value that I'm expecting. So I multiply the number of divisions by the times per division to get my period. I invert that value to get the frequency. What frequency am I expecting? Well, this waveform is a 60 hertz AC waveform, 120 volts, right? Just like you'd have in your house. Okay, so just to recap a little bit of what we've done here. Let me close this oscilloscope. We have built a simple circuit with resistors in parallel and series combination with a DC power supply. We added voltage and current probes. We added an ammeter, which has to break the circuit. We added a voltmeter, which does not have to break the circuit. We added a multimeter set to measure voltage, DC voltage. We built an simple AC circuit with 2 resistors in series, AC power supply, again, a multimeter, but this time set to AC volts, and a voltmeter here, again, set to AC volts, which is measuring RMS voltage there. Okay, so you are doing something similar to this for Lab 1. Be sure not to just follow along with what I did in the video, but actually read each part of the lab step and make sure that you're recording all the information that is required of you in that lab. Okay,